So today we are going to start with our main chapter that is known as motion. And I hope that most of you already know about the concept of distance, displacement, and speed velocity. How many of you already have idea about distance, displacement, speed velocity? Any one of you that already studied about speed, velocity, acceleration, distance, displacement? Okay. Okay, so I'm just going to cover this topic very quickly because that was a very basic term and basic definitions and the basic difference. I will also share a link of recorded lecture. So if you want to learn or if you not get the concept after the class, and I hope you got the concept, that was not much very difficult. Okay, so first of all, let's quickly start with distance, the concept of distance. So basically, distance is a simple length between 2 points, or we can say that length of a path, length of a path covered by a body. There are multiple definitions, so you may write, if you want to write any other definition, it's up to you. That was not a problem. And I'm writing a just simple definition that will give you a clear concept that what actually distance is. Let's suppose if you are having 2 points, let's suppose if you want to walk from your home to your school, so your starting point is your home and your ending point is your school. So you are basically going to cover the length of a path or the distance, or in simple word, you need to cover all length between your home till school. So that is the concept of distance, right? Assalamu alaikum, Umair. Umair, we just
What?
started the topic of distance, right?
Oh, you did? I didn't see it in the recording.
Okay. Just we just started with the distance because motion is a detailed chapter. So distance, displacement, speed, velocity, these are very common definition and common
Wait,
concepts.
so I have a question. Did you
Yes.
start it with this class or like with the previous class?
In this class, this was the first. This is the first class of chapter motion.
Okay, sorry.
Last time was that momentum. Only one class for momentum.
Yeah, okay.
Okay, so basically, if we are talking about a distance, so basically the length which we covered between 2 points or length of a part covered by a body in simple word is known as distance. And if we want to talk about the symbol, so the symbol for distance, basically there are two different symbols. It's up to you if you want to use a small s or a small d. It's up to you. These are two symbols for distance. In some books they used to write s, in some books they used to write d, but there is no negative marking, or there is not a like a concept that you always you need to use this symbol or that symbol. It's up to you, either you are going to use s or d. And further, we need to write the SI unit. From the definition we know that we need to measure a length. So what is the SI unit of length? That was a very basic concept. We know the SI unit of length, and that is,
Meters.
yes, meters, small m. And one more thing, if we want to categorize this quantity in scalar or vector, so in which quantity distance falls, in scalar quantity or vector quantity? Because vector quantity requires direction. So there is no direction involved in distance. So it is a scalar quantity. Scalar quantity are those. So when we are talking about scalar quantities, so scalar quantities are those quantity that only contains magnitude and SI unit, no direction involved. Okay, now if we simply compare this concept with the concept of displacement, so these are a type of same concept, but still there is a difference between and displacement scientifically. Let's suppose, first of all, if you want to write a definition, so very simple definition for displacement is between points or shortest distance covered by a body. And we need all the points already written in the column of distance. Okay, for distance and displacement, we are using same symbol, S or D. So again, the symbols are same, S or D. And SI unit is also same, meter, small m. The difference is all the concepts and all the parameters are
It's a
same.
vector.
Yes, it's a vector, so we need to include one more thing in our definition, this shortest distance covered by a body in a particular direction, right? So in a particular direction or in a specific direction, so that completes the definition of displacement, because
So
it is
why
a
does displacement have direction but not distance?
yes. Basically, in just like if someone asks you that how long it will take to travel from this point to some other point, let's suppose if you want to walk from your school to some park, so you roughly estimated tell someone that it will be around 1 or 1.5 kilometer, right? So that is completely distance. And if someone asks you about the direction that I want to go to this place, so you just guide me, so you completely guide with reference of direction. So that is the concept of displacement while using Google Maps. So basically, using Google Map gives you a concept of displacement because it shows you the magnitude of length between 2 points, your destination and your starting point. Also, it all shows you the direction. So that is displacement, right?
Okay, I understand.
So that is the concept. So that's why it is a different from distance, that is displacement, and it is a vector quantity. And why we are writing shortest distance, because we know that if we are moving in a particular direction, so that will be the shortest path, right? Because we will always try to cover distance in a very short time, right?
Yeah.
A very simple concept. I'm not writing in detail or explaining in detail because these are very common concepts already we studied many times. Our main concern in this chapter is to study about the graphs, right? Okay, so after that, in these quantities, we only talk about the length or a path covered between 2 points. If we want to compare these quantities, because these length or the length concept of the length is a basic quantity. It is not a drive quantity. And if we combine this concept of length with the concept of time, so dividing distance or dividing displacement with the time will give you a new quantity, that is the quantity of speed or velocity, right? So new quantities will be a quantity of speed and velocity, right? Because till now we only talk about the length, specific length. So that is a base unit. And when we are going to talk about the speed, so basically the concept of speed is distance covered by a body in a unit time. Distance covered by a body in a unit time, or we may in 1 second, because we know the SI unit is second, so we may also write 1 second. It's up to you that you are writing a unit time or 1 second, it's up to you. So basically distance covered by a body in a unit time. And if we want to write the symbol, so the symbol for speed is V. V is the symbol. And the SI unit for speed is meter per second. Because the SI unit for distance is meter, first of all you need to write the SI unit of distance, then you need to write SI unit of time, right? So it will be meter per second. Meter per second, or in short, meter per second, or you also write meter per second like this. So there are multiple variation in writing the units. And the last thing, again, speed is a scalar quantity, right? Because there is no need of direction in it. Because when generally we talk about the speed of car or speed of different vehicles, so that is the concept of speed only. But specifically like in engineering, or when we are talking about the airplanes, so they need a specific direction and also specific speed. So when we are talking about with the reference of speed with a specific direction, so that is the concept of velocity, right? So the definition of velocity is, okay, there is one more concept. If you are not going to write in a unit time or in a specific time, so you may also use a concept of word rate. Rate of change of displacement, rate of change of distance, right? Let's suppose if you want to write the definition for velocity. So basically rate of change of,
Speed.
no, rate of change of displacement,
Ah, okay.
because first one is related to distance and this one is related to displacement, because this is a vector and there will be a specific direction, right? So this is specific for velocity. You may also write the same definition for speed, just replace displacement with a distance. And why we, because in our daily life when we are using the term rate, so normally we are going to use this term because when we want to exchange product or when you want to buy product or something, so we exchange our currency or money in the form of product, right? So basically in our daily life we use word rate, and the meaning of that rate is related to our money or currency, right? So same goes for scientific terms. So when we are using word rate in chemistry also, so that gives you the concept of that you are going to divide that quantity with respect to time. So whenever we want to divide any quantity with respect to time, so may use the concept of word rate, right? So that is a very short form, rather than writing covered by a body in a unit time or in a 1 second. So that is a very simple concept that you just simply write rate of change of displacement. Okay. And again, if we talk about the symbol and SI unit, so symbol remains same, SI unit remains same. Okay, let's suppose if someone asks you that if you want to write different symbol for scalar and vector quantity, let's suppose if V is written in our paper and someone asks you that is it velocity or speed. So how would you identify that is it velocity or speed? Because symbol of both speed and velocity and distance and displacement are same.
Velocity will have positive and negative
Yes, very
values.
good. So velocity have positive or negative factors, and if you want to show with the symbol, that is not compulsory in your exam, and they never ask you to identify a difference between speed and velocity in symbol. So if you want to differentiate in symbol, so for vectors we usually draw arrow on the top of the symbol, right? So that
Yeah.
concept of a vector quantity, but that is not important, right? I'm just giving you a concept that if symbols are same, so how we are going to identify, right? Because now we are writing definition and complete concept, but if we want to identify in form of symbol, so how we are going to identify, so that is the concept. And the last thing is it is a vector quantity, and finally when we talk about their formula, so formula will be, so formula for both speed and velocity will be same, because all symbols are same, SI unit are same. So V is equals to
Distance over time.
S over T or D over T. It's up to you. I hope there will be
Yes,
no.
sir. I used to do S is equal to D over T.
Yes, it's up to you.
Okay.
All clear? Any confusion?
No, sir.
Okay, let's quickly move towards new section of acceleration. because these are basic definition, only basic concept, and after doing many questions you automatically get the concept of these quantities. So you don't need to give extra time over these topics because these are just basic terms. So next term is related to acceleration. Okay, we already studied about speed or velocity, right? Now we just generally talk about acceleration. So basically,
Uh, the rate of change of velocity.
yes, very good. Simple, because first we start with length, then we divide length by time. So that is drive quantity, velocity. Then we will continue with acceleration. So rate of change of velocity is known as acceleration. You observe in a vehicle there is a component named accelerator. So basically the concept of accelerator is same. That will change your speed with respect to time. Either it is going to increase or decrease. The same concept that Gan already included, that velocity will be positive or negative. Okay, so basically rate of change of velocity is known as acceleration, right? A very simple concept. And if you want to quickly write about the symbol, so symbol will be small a, and next thing which is related to SI unit.
Meter per second square.
Yes, meter per second square, because velocity have already unit meter per second, and there is again a concept of
Time
rate.
has, yeah, second.
So again there are two times the seconds included, so that's why we use meter per second square, or ms minus 2. And again acceleration is a vector quantity because direction is already included in velocity,
Yeah, velocity.
and the formula will be like a is equals to v over t.
V minus U over T.
Yes, a very simple concept. This is the formula acceleration. Okay, so basically the concept of velocity that we already discussed, that it will be positive or negative. Positive, negative in a sense. Let's suppose if you push accelerator of your car, so your speed will increase, right? So let's suppose if we consider increase of velocity as a positive, right? Because that is just a reference of direction, just like the graph. We used to mark positive x-axis and negative x-axis, right? And just like y-axis also, z-axis also. So basically there are two directions normally in 2D, and if we are talking about 3D, so we are having another axis, z-axis. So let's suppose if you are moving and if you increase your speed by pushing accelerator, so your speed will increase, and we consider that change of speed as a positive, because that will give you a positive change because you are increasing. And let's suppose if you pull back the accelerator of your car, so your speed is going to be decreased, right? So that is something different. So basically acceleration is rate of change of velocity, but velocity can be changed in two different form. Either it is going to be increased or either it is going to be decreased. So let's suppose if we consider both concepts. So if we talk about normal concept that is related to acceleration. So when we are talking about simple acceleration, so in concept of simple acceleration, velocity or speed will increase. So velocity or speed will increase. So when we are talking about speed and velocity and both are increasing, so that will give you a positive acceleration, right? Positive acceleration. I'm drawing arrow over it, so that will give you a concept of acceleration A. Otherwise, you will confuse after the class that what is A, is it something different or not? So that is the concept of acceleration. And let's suppose if velocity or speed decreases with time. Okay, now generally or in generalization, there is no difference in writing speed and velocity, because 99% questions are related to only magnitude, because we are studying basics. So velocity or speed will decrease. So if velocity and speed of a body will decrease, that will give you negative acceleration, right? And this negative acceleration have some other name also, that is known as,
Deceleration.
yes, you may write deceleration,
Retardation.
retardation. So these are different names for negative acceleration. Okay, just writing a number for example, if someone is not getting point how it will be negative. So let's suppose there is an example with, let's suppose we are having initial speed. Okay, so let's make it delta v because there is a change in speed. So it is better to write delta v because it gives you a concept of change. So let's suppose we are moving with initial velocity. So initial velocity will be 40 meter per second, and our final velocity is 25 meter per second. Observe, initially we are moving with a greater speed, then we are moving with a slower speed. So whenever you want to calculate the formula or the value of acceleration, so always we find difference by a final value minus initial value divided by time. So whenever you write 25 first and minus 40, so you know that you will get negative answer, right? So basically that negative answer will never tell you that acceleration is something in opposite direction or like that. That will give you a concept that your speed or velocity is decreasing, right? So that is the concept of this positive and negative acceleration, right? So your acceleration will be minus something meter per second square. Any confusion?
No, sir.
Okay. Okay, furthermore, there are some different quantities like uniform or variable velocity, uniform acceleration, variable acceleration. So let's suppose if we consider uniform speed or uniform velocity, or you may also write constant speed or constant velocity, all gives you a same concept of a uniformity. So basically uniform velocity means, let's suppose if we are going to increase our speed, initially we are moving with 10 meter per second, then in next second we increase our speed by 2 meter per second. Let's suppose we starts from, our starting point is 10 meter per second, and after 1 second our speed will increase 12 meter per second. Again after 1 second our speed will be 14 meter per second, then 16, then 18, like this. So you observe that your speed is increasing, right? But in a constant way, in equal interval of time. The first change will be in 1 second. This change happens in 1 second, and again this change happens in 1 second. All change happen equally in an equal interval of time. So when you are moving equally in both concepts of time and distance, so your velocity will be constant or uniform, right? So you may just simply write when a body equal distance or displacement, because talking about difference right now, we're just writing a concept of uniform velocity or speed. So when a body covers equal distance in equal interval of time, so that is a concept of uniform or constant speed or velocity, right? Because our speed is increasing but the change of the speed is constant, right? Okay, one more thing, sorry, I just mistakenly write the unit of speed over here. We are talking about velocity or speed and there is a change.
Yeah.
Yes, sorry for that, you need to replace it by only meter. 10 meter, then 12 meter, then 14 meter, right? Then 16 meter. So basically, your distance is going to be increased by 2 meters after every 1 second. So you observe that you are increasing your distance in a constant way, right? Your magnitude is increasing as compared to the initial value, but still you are going with a same value, right? Let's suppose after moving 16 meter, we start moving like after 16 we will get to 20, then 22, then 26, then 29, then 29.5. So that is a random change. So that random change is known as variable velocity, right? Because there is no specific pattern and there is no constant change in the speed or velocity, right? So let's suppose initially you are walking, then you start running. So that is the concept of variable velocity. So whenever you want to write about variable velocity or variable speed, so the concept of variable velocity or speed is unequal distance, or you may also write does not cover equal distance in equal interval of time. So both are the possibilities. And let's suppose the interval of time, because time is independent quantity. So that's why we are not going to control the time. We are just using a stopwatch to measure the intervals. So when a body covers unequal distance in equal interval of time, so that is the concept of variable velocity. Okay, so in this case, we write values like that. Initially, we start from again 10 meter, then we next complete water only, then suddenly move to 15, and again we move to 22. So you observe there is a random change, right? There is no specific pattern. So all is going to happen in every of time. So in that case, you saw that there is a variable change. So that's why we write this quantity as variable velocity or variable speed. And same goes for the acceleration, right? So there is also a concept of variable acceleration and constant acceleration. And let's suppose if we are talking about a constant speed or velocity, so what will be the value of acceleration over here? If you want to write the value of acceleration over here,
Zero. Zero.
okay, so acceleration is equal to zero because we know that
Yeah.
there is no change in time. So that's why, sorry, there is equal change in distance with respect to time. So your acceleration will remain same, that is zero, right? Because you are not going to increase your speed, only your numbers are increasing. And when we are talking about variable velocity, so now you have a concept of both positive and negative acceleration depending upon the situation, right? So acceleration may be positive, acceleration may be negative. And whenever we are going to talk about constant acceleration, so same concept again, equal change in velocity in equal interval of time. And we already discussed the concept of change in velocity with respect to time, that was by mistakenly written in the first concept, equal change in velocity in equal interval of time. You know, these definitions concept are like a simple or the basics. but we need to study from the start because maybe somebody don't know about this concept. So I know it's a boring one concept because most of you already know about this. So that's why I'm just moving very quickly in this concept. Second concept again, the same variable acceleration. We already talk about constant acceleration, so this will be variable acceleration, and this will be there are in different definitions in your textbook and your notes, but you may write any definition, only concept will be clear, right? So unequal change in velocity in equal interval of time. Any confusion till now?
No, sir.
Any question?
No.